going to say, you know what? I don't know what the zeros are. Looking at this monster, this thing is huge. So step one is going to be, let's make a list of possibles. Once we have that list of possibles, step two is to graph it with your graphing calculator. And I'm just going to use GC for graphing calculator. Graph it with your GC. Find any nice ones. Any nice zeros. So we look at the table and we see 2, 0, 5, 0, 6, 0. Take them. I mean, that's what the graphing calculator is for. Grab them when you can see them. But because we do make mistakes punching things into the graphing calculator, step 3 is going to be verify synthetically. Verify with synthetic. Our math magic. That your remainder is 0. Because you could have punched it in wrong. You punched stuff in wrong. It happens. Now, sometimes we'll see them all. We'll be able to work this synthetically all the way down and find every last 0 that there is. But sometimes we're going to have to work this down to step 4, which is we'll get a quadratic and we'll have to use the quadratic formula. Because in the end, we want them all. And yesterday we talked about how it's easy to know how many you're supposed to have because you just look at the degree. The degree tells you how many answers you were supposed to have. So let's back up, take this problem step by step. Step 1. List the possibles. What number are we going to use up there for the top of our fraction?
1.
No. 4. Remember, this is bottom and this is top. B before T. Okay? Bottom, top. So what we have to do is use the top here, plus or minus 1, plus or minus 2, plus or minus 4. Those are all the integers that divide really nicely into 4. Now we go to the front. What number is in front of this thing? Even though it's not there. 1. Well, this is going to be a nice little short list, like that. Because 1 divided by 1 is 1, 2 divided by 1 is 2, and 4 divided by 1 is 4. Those are possible zeros. They're not all going to work, they aren't. But it's a possible list, a starting place. Now, if we had to do this by hand on the MCAs or the ACT, there's only 6 of them, and we're pretty good at synthetic, so it wouldn't take forever. But we don't want to have to do that. We're going to say, let's use that graphing calculator and go to step 2. So step 2 is to punch in y sub 1 equals x to the 5th minus x to the 4th minus 3x to the 3rd plus 3x squared minus 4x plus 4. And we're going to check and see if any of these work out nice. So x to the 5th minus x to the 4th minus 3x to the 3rd plus 3x squared minus 4x plus 4. Easy to make a mistake punching something like that in. It's a monster. It's an absolute monster. Now, let's try Zoom 6. And hope we see some. Ooh, -2 looks really good. 1 looks good and 2 looks good. Those were on our list. Let's check in the table. Second table. There it is. -2, 1, and 2. So we found them. We used the graphing calculator. We found the nice zeros. It looks like they're at -2, 1, and 2. But again, I might have punched it in wrong. So maybe these won't work. So to make sure they're going to work, I have to verify synthetically that those are zeros. So let's see what we have. Little -2. I'm going to start here with all of my coefficients. 5, 4, 3, 2, 1, 0. They're all there. So I need a 1, a -1, a -3, a 3, a -4, and a 4. We need to get a 0 for the remainder, or we punched it in wrong. So bring the 1 down, multiply, add, multiply, add, multiply, add, multiply, add, multiply, and add. We were right. -2 is one of the zeros. And because it worked, we're not starting over. We're going to use this shortened one now with 1 and 2. So I'll just do 1 next. Doesn't matter which order you do these in, by the way. It makes absolutely no difference. So, synthetic with that one. Bring down that leading coefficient and do your multiplying and adding. Check to make sure yours matches with mine. Outside the box, multiply by 8. Inside the box, add. So does it work? Cool. Let's keep going. Let's use the last one. Let's put the 2 in. Oh, sure. Oh, your synthetic went wrong somewhere?
Yeah.
Now, the numbers to try, that was from the table in the graphing calculator. Anything that has a 0 for y is an x-intercept because it's going to cross the x-axis there. So, Mallory, if we just do second graph, see how these three, 2, 1, and -2, all have zeros for y. That's what we try. That's what we're doing right now. We're verifying these synthetically to make sure the remainder is 0. Anybody need more time before we do the last number here? All right, so let's synthetic this 2. Bring down your leading coefficient. Remember, outside the box, multiply. Inside the box, add. Did we punch it in right? Must have. They're all 3 working. So here is 0 number 1, 0 number 2, 0 number 3. Now, I've got a sneaky suspicion we're not done. Because there's still stuff here. So how many zeros were we supposed to find? 5. This is a degree 5 polynomial. Oops, 2 R's instead of 2 E's. So we need 5 zeros. Did you see it cross at any other spots than those 3? That means they're imaginary. So what we have to do is use what's left down here to find those last 2. So this is remainder, constant, x, and x squared. So this is really x squared plus 1 equals 0. I think we know how to solve that. We'd subtract 1 from both sides. So x squared equals -1. How do you get rid of squaring something? Square root. So x equals plus or minus what? I. The square root of -1 is I. That is 2 more answers. Do we have them all? We do. And that's our job. Our job is to find them all, whether or not we can do it by hand, by factoring, or we have to grab the graphing calculator and get some to start with. But we always want to work this down as far as we can and then find the rest of them using algebra as we go through these. All right, so step 4 was quadratic formula. We didn't need quadratic formula for this one. This one ended up being kind of nice and we could solve it. So I suppose we should put step 4 might be quadratic formula. It might be solve. It won't be factor, because factor would mean that they were nice. We would have seen those when we actually did the graphic. All 5 of them. Negative 2, 1, and 2, positive I, and negative I. Exactly. Whenever we do the square root piece, we've got the plus or minus piece. So negative 2, 1, 2, positive I, and negative I. Okay. All right. So let's give this one a go. Now that everybody's feeling a little bit better about this. I can see that because when I'm up here, I see some of you working ahead. I see that you're already on to the next step. All right. Take a look at the got it for 3. First of all, this has an issue. If we're going to find solutions, what do we have to do? Move her all over to one side. Can't have it on 2 sides. It's got to have a 0. Now, with this one, I would be really tempted to at least factor one thing. Yeah, take an X out of there. I definitely would say, gosh, I could take that greatest common factor out of there. But what's left is not factorable by grouping. But right off the bat, I could say, hey, I know one of the zeros. It's X equals 0. There's 1. Out of how many? 4. Yeah, we had 4 here with X to the 4th. So let's do the possibles. Hey, did you notice in the last one, 3 of our zeros ended up being in our list of possibles? It happens. So this time it's like, well, what are we supposed to do though, because we don't have a constant in the back? Well, this is one of those times where if you don't have a constant, you do this factoring so you can get a constant. So if we have a 10 in the back, that's plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. Better going to go into that. And what number is in front of my x cubed there? 1. Luke?
What if the 10x be positive?
Oh, thank you. Thank you. Missed it. There we go. So our possibles are going to be plus or minus 1 divided by 1 is 1, 2 divided by 2 is 2, 5 divided by 1 is 5, and 10. So there's some pretty good possibles again. Alex.
So is it always 1 at the bottom?
It isn't. Every once in a while we're going to see like a 2x to the 4th or something like that. And then
So
we'll have to
it'll
put
be
the
2?
factors of 2 on the bottom, which would be plus or minus 1 and plus or minus 2.
And then on the top, it's always factors that go into the 10,
The last number.
which is the constant.
Yes.
Okay.
So factors of constant over factors of leading coefficient. Because there's, here, let me put it in there. Little imaginary one up there. Okay? So those are ones that are possible. We are really hoping that they are actual zeros. So what do we do next? What's the next step? Let's put her in there, see what happens.
We put the x,
Oh, good question. Luke says, do we put this x in here and then the parentheses and all that good stuff? We already found the 0 for this one. So we just really need this. You could also put in the original one. That way you'll know, yeah, 0 works. Look, it's all good. So I think I'll just put the original one in so that we can see 0 definitely works. X to the 4th plus 2x to the 3rd minus 13x squared plus 10x. Like I said, I'm just going to put the original one in because I want you to see it does cross at 0. That way we'll know our answer of 0 was right. Definitely crossing at 0. That's a good thing, but it's also definitely crossing in 1, 2, 3 other places. Let's see what those are. Second graph. Oh, look at that. 0, 1, and 2. But that other one looked at, oh, there it is, -5. So I had to go back a little ways on my table to see -5. We already know about 0. So -5, 1, and 2 are the ones we should try. Now, since we already know about the 0, we can just start right here with the black underline. If you wanted to verify 0 synthetically, you could go way back up to the very beginning and start this one.
So you get the -5, 1, and 2 from the table?
Yes. Wherever you have a 0 for y. Because really, let's put the visual together with this, everybody. What it's saying is, we want to find all of the nice ones where it crosses the x-axis. When you graph on the x-axis, it's going to be some number, but then no up and down. So it'll always have a 0 on the y. That's why that's happening in our table. So let's go with, we'll start with the -5. I guess I just usually always start with the negative ones and get them out of the way. So now we're going to use, because we already took the 0 out, 1, 2, -13, and 10. And one of the things that I'm checking for is there anything missing? But once we factor out that piece, there isn't anything missing. Everything's good. Now do your synthetic. Make sure you get a remainder of 0. And down your reading coefficient, outside the box, multiply by 8, inside the box, add. Is that a good thing? Means -5 works. So now I'll try 1. Looks good. So let's try 2. Let's verify that last one from the calculator and see if it works. Do we have them all?
Yes.
How many were we supposed to get?
4.
4. Then we got 0 from factoring. And then we got -5, 1, and 2. 4. Got all 4. Cool. Like I said, you wouldn't have had to do the factoring here. You could have used your graphing calculator right away and found all 4 of these, 0, -5, 1, and 2, and gone through this synthetically. All right, starting to come a little better. 4, 3, 2, 1, 0 me right now. When it says find all the solutions, where's everybody going? Okay, a couple of you still a little hesitant. That's good. We're not done. Keep going. Following the steps. Notice it still just says finding all the zeros of a polynomial function. All right, let's start with how many should we have when we're done with this. So let's not forget that. We're supposed to have 4. So let's make our list of possibles. What number up there do you use for your possibles? 18.
Oh, yes.
Oh boy, this one has a lot, doesn't it? 1, 2, 3, 6, 9, and 18. All over what? Love it when that happens. At least we don't have to remake the whole list here. So 1 over 1 is 1, 2 over 1 is 2, etc. There they are. That's a lot of possibles. So yeah, grabbing the GC and getting what we can is a good idea. So, mighty graphing calculator, we need x to the 4th plus x to the 3rd minus 7x squared minus 9x minus 18. Oops, that's not an 18. That would have messed me up big 18. Boom. Zoom 6. Looks like -3. +3. -3 and +3. Let's check the table. Second graph. -3 and +3. There they are. So let's try them. Let's make sure, because I almost punched this in wrong. I hit the 9 instead of the 8, so you gotta make sure. Everything there? In order? Okay, good. So 1x to the 4th, 1x to the 3rd, -7x squared, -9x, and -18. Do your synthetic. Let's make sure we're getting a 0 in that last position. So far so good with the -3. Okay, it's working. Now let's keep rolling with the +3. Anybody need more time to get her synthetic? Okay. And our goal is, do we get a remainder of 0 here somewhere? So are these 2 zeros or not? Got our remainders of 0, so there's 2 of them. Here's the problem. Is this supposed to have 2 zeros? It's to have 4. There's stuff left down here. So we have to figure out what is this stuff. Well, remainder, constant, x squared. So that's going to be 1x squared plus x plus 2 equals 0. Oh, for goodness sake. Good. Having a fit, smartboard. All right. Now, we know it's not going to be factorable. If it were factorable, we would have seen it on a graphing calculator, but we could try just to show ourselves, hey, this doesn't work. We would need 2 numbers that multiply to 2 and add to 1. Isn't going to happen. No, they have to multiply to 2 and add to 1. It isn't going to happen. So at this point, we'd say, okay, quadratic formula, at least they're small numbers. A is 1, B is 1, and C is 2. And don't forget the sum, x equals -b plus or minus the square root of b squared minus 4ac all over 2a. We're going to plug these in. We're going to simplify it as much as we possibly can. And Faith and Forrest are going to pay extra close attention because you can't see when your eyes are closed. -1 plus or minus the square root of 1 squared is 1. Minus 4 times 1 times 2 all over 2 times 1, which is 2. Now it's just that nasty radical that we need to deal with. So x equals -1 plus or minus 1 minus 8. 1 minus 8 is? I'm pretty sure we can't leave that. What do we have to do? So x equals -1 plus or minus I squared, it's a 7 over 2. Woo! Do we have them all? But this is only 1, right? 2 plus or minus. Remember, imaginaries always come in pairs. So we had our 2 nice ones and 2 not so nice ones. But we got them all. There they are. So our job is find them all. It's a long process, isn't it? Okay. It will be. Yeah, and that's because imaginaries always come in pairs. So do nasty radicals. Like if we had the square root of 3 as one of our answers, there's going to be something with a negative square root of 3 in there too. Okay? Candy partners or not?
No, it's a silly chicken.
Yes. Do it.
Yeah,
Candy partners.
All right, we'll do chicken wing elbow
I
partners.
mean, I want candy, but.
Let's talk through it in steps then, okay? Let's talk through it in steps. How do you start?
Well, it's already equal to 0, so you're good.
Already equal to 0, fantastic.
So you do the 6.
6? Okay, what goes into 6, everybody?
1,
2,
2, 3.
6. 1 and 2.
1 and 2.
Nailed it.
So this is going to be a little longer list. Obviously, we can go through with the 1 and get 1, 2, 3, 6. But we also need to go through with the 2 on the bottom. 1/2. Yep, we already have the 1. We've already got the 2. 3 halves, we don't have that down there yet. 6/2, is that on this list yet? Got it. So here's what we're doing. We're taking 1, 2, 3, and 6 and putting them over 1. That gives us 1, 2, 3, and 6. Then you have to go back and put all of them over 2. 1/2, 2 halves is 1, 3 halves, 6 halves is 3. And get the list of possibles out.
Why do you have a 2? So why do
This
you have
time
a
it's
1,
not a 1.
2?
Those are the numbers that divide nicely into 2.
Oh, so if you had a 4, you'd do 1, 2, 2.
1,
If you had
2,
a 5, you'd do 1 and 5.
Mm-hmm. Yep, you always write down all the
And
factors.
if you had a 9, you'd do 1, 3, and 9.
So there's our possibles. What's next?
Y equals.
Land that thing in the cover.
Get her in there. Come on, GC, let's get her done. Get her done. 2x to the 4th minus 3x to the 3rd minus x minus 6. Zoom 6.
Oh, wow. That's fancy.
Looks like it might be what?
-1.
Yeah, so second graph, -1 and 2.
Oh, nice.
What do we do with those?
Synthetic.
Synthetic. -1. Let's see what do we have up there. Is it in order or is everything there?
Yeah.
Oh, we're missing stuff. 2x to the 4th, -3x to the 3rd, 0x squared. That would have messed us up right away. Oh, we already had? Yeah. If you miss a 0, ew, that could have happened.
Yeah.
Do the synthetic, then look up here to check. Are we good with -1? Got our remainder 0. Okay, so now do it. Keep going with the 2. Keep going. Sorry, Haley.
What?
If you punched it in wrong. Yeah. Now. Because we already said take all this stuff on the top and go over 1. That's what these were from. The rest of them come from 1/2, 2/2, 3/2, and 6/2. But 2 of them we already wrote down. We already have them there.
So,
This is just a list of possibles, Mallory. So that's looking at all of these little fractions that occurred because of the possibles. This is graphing calculator. We use the graphing calculator to find -1 and 2. And then do your synthetic. Done?
No, not you.
How many zeros is it supposed to have? 4. How many do we have? 2. So we have to see what we have left. Is that going to be factorable?
Right.
No. If it were, we would have seen them up there when we graphed it. It is not factorable. So yep, quadratic formula. I'll give you a head start on the quadratic formula. Don't rush. You'll make mistakes. Don't rush. But let's see if everybody can get the right answer for this.
I got it.
You weirdo. That's right.
That's why I got our two answers. This is the same thing we were doing yesterday.
Doesn't feel like it, does it? Because we only got through 2 yesterday, so it's like, we got 2. We went as fast as we could. That's all. All right, this is bragging time. If you just got all of this right, you raise your hand and you raise it high. Beautiful. Beautiful. So 4, 3, 2, 1, 0 me now on where everybody's at. Definitely improving the numbers already. Good, good, good. All right, excellent.
Wait, how will you know if it's factorable or
If we don't see them up there, then there's no way they're going to be factorable. If we, let's just say it crosses at like 2.5, Haley, 2.5 is not going to be in the table because our table has integers in it. So we'd go, well, what's that one? And those are the factorable ones. So if we see something up there but it's not in the table, then it could be factorable at this point. But if all we see are nice integers up there, there's no way this last one is going to be factorable. It just isn't. Usually it'll be imaginary because we can't see it at all. You know? All right, so that is a good place to stop. You guys are feeling really comfortable. I'm gonna get you some to do. I want you to look at that list. That's very short. Very short. Do not say, oh, I got it now. I don't need to do any more of these. If you do that, it's not going to work. Folks, your brain works this way. If you do something in class and then you do it again 12 hours later, your brain says, oh, I've had to do this again. I must need to remember this. If you just learn it in class and you don't ever do it again, your brain says, oh, that's short-term memory. Let me push that out and put something else in there. So don't let your brain push it out. Do these problems. Oh, 33 is not going to work. We're not going to see any nice ones up there, so this is just list possible so that you don't forget how to do that. For number 33, we're not gonna find any nice ones for 33.